Okay, great, guys. Let's continue with maths literacy. Let's work with formulas. Let's get straight into the next example. Example 4 here. It says Mr. Rugani throws a piece of chalk at a learner sitting chatting in the back of the class. This teacher's frustrated. You're supposed to be listening to the teacher. And what does he do? He gets cross with you, and I don't recommend this, but he loses his temper and he throws a piece of chalk. Now, what's going to happen is the chalk's going to go up and go down and hit the learner on the head, hopefully causing not too much damage. Okay, so let's see what happens here. Okay, he throws this chalk. Now we can actually mathematize. We can look at this. Okay, and the height of the h of the chalk in meters above the ground is calculated with the formula h is equal to 16t minus 2t squared, where t is the time period in seconds and h is the height in meters. Okay, so it kind of does this. You can imagine that Mr. Rugani picks the chalk up from the ground and then he lifts it up and throws it. And it goes and it lands on the desk of that student and maybe probably hits the ground as well. So let's do some mathematics with this thing. Okay, it says calculate the height after 1, 2, 3, 4, 5, 6, 7, and possibly 8 seconds. We want to see how high this thing's going. Okay, now, the way we can do it is pretty easy. I'm going to go to a sheet of paper here. We've got time in seconds, and we're going to work with this particular formula. Okay, now how does it go? Let's have a look here. If we have a look here, we know that the formula for h is going to be this. H is equal to 16t minus 2t squared. So the formula is going to be, okay, so the formula is going to be h equals 16t minus 2t squared there. And here we've got our table, and we've got noughts, seconds, 1 second, 2 seconds, up to 8 seconds. So it probably took about 8 seconds for it to go up and down. Watch out. 1, 2, 3, 4, 5, 6, 7, 8. That student is going to be listening now. Okay, now what do we do here? We can see, okay, we've got this here. We can easily work out from h is naught. So if h is equal to, or if we've got 16t squared and we're going to plug in naught, okay, let's put in naught there. Well, that's easy. You don't even have to worry. That comes to naught. So h is naught. So we can fill in a naught there. Now, what about h equals 1? So if we put in 1 into the formula here, okay, what does this give us? Okay, well, that's easy. If you use your calculator, we can do it, but this is so easy. 16 times 1 is, and this is 1 squared. That's so simple. 16 minus 2 is 14 there. So that's going to give you 14 meters. Let's write it in. Now, what about if we have h is equal to 16 times 2 minus 2 times 2 squared? Let's see what we get here. Now, if we work that out, there's 16 times 2, so it's 16 bracket 2. I'm doing exactly what the calculation said. Subtract 2 times 2 squared. Okay, this is going to come to 24. Okay, so we can write 24 there. So let's put in 24 there. Now, what about if we go to 3? 16 times 3 gives you 2 times 3 squared, which is going to give us, what's that? Well, 16 times 3 is 48. Subtract 9 times 2 is 18. We'll come to 30 there. If we look at that, 30, great. So we can write in 30. Now, what will happen if we go 4? So this was 30 here. What about h equals 16 times 4 minus 2 times 4 squared? Well, let's see. 16 times 4 is 64. So let's go 64, subtract 16 times 2 is 32, giving you 32. Okay, now, there we go. Now, what's going to happen? I'm not going to actually do the calculations. You can check it out. But this is what happens. This goes 32. This goes down to 30 after 5 seconds. And then we're down to 24, back to 14, and then we land up at naught. So what's going to happen is something very interesting here, is that we get this movement from naught meters up to a maximum of 32, and down we go. Now, we can put this on a graph, guys. We can actually do this. Have a look at this graph. If we go to a graph here, we can represent this. If we have a look at it, it goes naught, naught. Okay, so let's put a dot, naught, naught. Then after 1 second, it hit up to 14. Okay, very important this. Then after 2 seconds, it goes all the way up to 24. And then after 3 seconds, it goes to 30. There we go. And then after 4 seconds, up to 34 or 32 there. There we go. That's its maximum at 32. Then it comes down after 5. It's going to 30. So it's there. 5 goes to 30. And then after 6, it goes to 24. meters. Now it's coming down. After 7, it hits 14, and 8 is 0. Now what has actually happened is that the thing has moved like this. It's gone up, reaches a maximum height, and then the chalk comes all the way down. And this is a lovely graph of the equation of the motion. Okay, quite nice there. Have a look at another one quickly. Body mass. If we have a look at a person's body mass index, can be calculated by BMI as M, where M is the mass of the person and H is the height of the person. So if I said to you, if Peter's BMI, body mass index, is 24 and he is 1,73 meters tall, how much does he weigh? Well, very easy. There's substituting. Look at 24 is the mass, the height is this, and you simply use a calculator to do that. Watch this. If we multiply both sides by the decimal, those cancel, and look what we have. M is equal to this, and you use your calculator to work out this, and there we go. His mass is 71,8 kilograms. Guys, powerful stuff, especially the graphs. Don't go away. We're going to do some wonderful math literacy in the next part of this lesson. I'm enjoying being with you. Stay with us.